Hello everyone, welcome to our video by your one and only Carl Querme. Today we're gonna talk about the Pearson correlation, which shows the linear relationship between two sets of data. In simple terms, it answers the question, can I draw a line graph to represent the data? Pearson's correlation coefficient is the best statistics that measure the statistical relationship or association between two continuous variables. It is known as the best method of measuring the association between variables of interest because it is based on the method of covariance. Two letters are used to represent the Pearson correlation, Greek letter rho for a population and the letter R for a sample. We are gonna have a sample question, but before that, let us go to the formula of Pearson correlation, which is summation of xy times n minus summation of x times summation of y divided by the square root of n times summation of x squared, summation of x, then the squared times summation of y squared times n minus summation of y then squared. The formula may look hard to remember, but just remember, this then just change the variable x to y. So we have our subject, then our two variables, which is age x and glucose level y. And the sample question, find the value of correlation coefficient from the following table. Step 1. Make a chart. Use the given data. And add 3 more columns, xy, x squared, and y squared. Step 2. Multiply the numbers in column x and y. Step 3. Square the numbers in column x. Step 4. Square the numbers in column y. Step 5. Add up all of the numbers in columns and put the result at the bottom of the column. The Greek letter sigma is a short way of saying sum of. And we have our result, which is summation of x 247, summation of y equals 486, summation of xy equals 20,485, summation of x squared 11,409, summation of y squared 40,022. After that, we will use the formula and replace it with the numbers we had solved. And remember that n is equals to the number of given in one variable. Then we have our r, or computed value, which is 0.53. And we have our HO, which is our null hypothesis, and our HA, which is the alternative hypothesis, and our alpha, which is 5%. Then the DF, which is n minus 2, and our n is equals to 6. We can get the TV by using the value of DF as the column and the 5% as the row. Then we will get our tabular value, which is 0.811. After that, we make our decision. We will compare the computed and tabular value. And always remember that if CV is lower, we will accept the hypothesis. If it is higher, then we will reject the hypothesis. Since CV is lower, then HO is accepted. Potential problems with Pearson correlation. The PPMC is not able to tell the difference between dependent variables and independent variables. For example, if you are trying to find the correlation between a high-calorie diet and diabetes, you might find a high correlation of it. However, you could also get the same result with the variables switched around. In other words, you could say that diabetes causes a high-calorie diet. That obviously makes no sense. Therefore, as a researcher, you have to be aware of the data you are plugging in. In addition, the PPMC will not give you any information about the slope of the line. It only tells you whenever there is a relationship. Now this time, try solving example 1 and 2 yourself.
You can do it. Don't give up.
Now this concludes our video. I hope you enjoyed and understood the video. This has been Carlo Kramer, your speaker, and credits to Valerie Curbita for making the PowerPoint and Rachel Milo for editing the video. That's all. Goodbye.